All right, so now we are on to Unit 3. The first topic in Unit 3 is water cycle, or the hydrological cycle. At the top of your notes, you're going to notice the picture exactly like this. Maybe not the arrows, you might want to draw those in. But what we're going to do is we are going to label the arrows so that you have that information for later use. The first one we're going to start with, we're going to skip 1 and 2 for right now. We're going to go straight to number 3. Number 3 is the drippy drops. The drippy drops are precipitation. Now, they could either be in the form of rain or they could be in the form of snow. And they're going to fall from the clouds. Once they hit the ground, they're going to do one of two things. The first thing that they're going to do, number 4, is infiltration. So think of infiltrate when two entities are going against each other. They like to try and infiltrate each other and deceive and spy and whatnot. So that's kind of like the same thing, except water is infiltrating the ground, infiltrating the soil, going down into the soil. And it will go down all the way until it hits this thing right here. This thing right here is called the water table. So that water table is that water above this layer of rock called impermeable rock. The water can't go through it, so it kind of just chills out above that rock underground. Another way precipitation can fall or go once it hits the ground, it's not infiltrating because there's too much or too high of a slope. It starts to run off. Number 5, go down the hill. This could be like streams or rivers or something like that, following it down, right? All right, so all of this water is following all the way this, and in the water table, under a big lake, like maybe Onondaga Lake or on Lake Ontario, you may find something called a spring. A spring is little areas that the water table has broken up into that body of water, be it a lake, a pond, or something of that sort, even rivers or streams. All right, well, once that happens and it gets into this body of water, and it's hot enough, or sometimes even if it's cold, it still does it. It evaporates. So it's evaporating off of water. One way to look at it is you got that V. V is like 1/2 of W, evaporating off of the water. It's so weird, I know. But another thing that can happen with water is you have these up arrows. These up arrows into plants, trees, flowers, any of them. That is called capillary action. So all of these plants are sucking up the water from the ground. And once they get into these trees or plants or whatever, I'm going to look at trees, it causes those trees to also lose the water via air or gas form, which is called transpiration. So evap over water, transpiration over trees. TR, tree, transpirate, that's how I remember it. Now here's the thing. You have all this water vapor coming off of the trees, all this water vapor coming off the water. Well, they're not just going to sit there separated. They're going to merge together to cause evapotranspiration. Yes, that's a word. It's a mixture of evapo and transpiration. Put them together. Now, number 2, right here, this going over this way to form the clouds, you're either going to look at dew point or condensation. So condensation will form the clouds when it hits dew point. All right. So, as precipitation hits the ground, it can do, like I said, one of two things. It can either infiltrate or it can run off. It depends on the slope of the ground. We're not talking about mathematical slope. We're talking about elevation slope. How high the hill is, how steep it is. So how fast the water infiltrates into the ground depends on the soil's porosity or the space between the material. This is huge. This is a big thing in earth science. So please remember, porosity is the space between materials. One way that I remember it is those O's are big circles. There's lots of space in the O's. That's how I remember it. So a soil that has lots of porosity or pebbles will allow the water to infiltrate quickly. So my example is right here. These right here are what you could be considered pebbles, and there's lots of space. You can see the space in between them. There's big space. So water will be able to get through that relatively easy because there's a lot of open space. The rate at which, like how fast it can go and get through there, is called permeability. So the rate at which water goes in the ground is permeability. It's typically centimeters per second or something of that sort. Sand, silt, or clay would have a much smaller porosity or spacing between the particles, thus would infiltrate the ground much slower. That is my picture right here. So gravel would kind of be like the pebbles. Sand would be like my yellow, or sorry, not yellow, my white beads right here. And you can see the white beads compared to the black beads. The white beads have a lot less porosity than the black beads, which means it'll go faster through here than it will through here. And just like you see here, same amount, same container, same size container, same amount of water is poured through. And to get through the gravel, it takes only 2 minutes. But to get through the sand, it takes 20 minutes. To get through the silt, 2 hours. The clay takes 2 days. It's a huge, long time. All right, so water will continue to infiltrate into the ground until it hits a layer of rock it can't get through, called impermeable. Another word to know is saturate versus unsaturated. The water will continue to infiltrate until the ground has hit saturation. If it has hit saturated, if it's totally saturated, no more water can get in it, and then it'll run off. If it is unsaturated, then water can still infiltrate until it hits that impermeable rock. Remember what I said? It's that rock that it can't go past it, so it stays right there on top and it flows, called the water table. The water table is a feeder source for ponds or lakes through openings in a bottom called springs. So you have all this water table and then like little breaks come up through and it's springs. What's really cool is there are some videos that show springs forming where it just broke up and it is forming, the springs are forming streams of their own to get to a bigger source. Or you could see the springs coming up in a stream already, making a little bit of an alcove almost for more water to go in there. So for water to go up into plants or trees through roots, it has to go against gravity. For that to happen, the spacing or the porosity has to be really, really close. This type of movement is called capillary action. Now, a lot of people, when they're bored, especially I've done this many times where I'm in a restaurant and I have my beverage and I have my straw and I put my straw in there and I get the water to go up the straw by just like pulling it up. That's capillary action. And if you think of this, if you have a small straw versus a big straw, so a really, really tiny one versus one this big, it's going to be easier to get the water up the smaller one than it is to get up the bigger one. That's looking at porosity. The smaller the size, the smaller the porosity, the easier it is that that water is going to go back up against gravity. All right. So water in ponds, lakes, and streams, they evaporate. Don't forget, water with the V, ponds, lakes, streams, the big bodies of water, they evaporate when it gets hot outside. And the water goes from liquid to what is called water vapor or the water gas. Water also evaporates from trees. But it's not really called evaporation from trees. It's called transpiration. It's kind of like respiration. It's breathing out that water, transpirating. If you add these two together in the air, the evaporation and the transpiration together, it forms evapotranspiration. And when the water vapor rises high enough in the atmosphere, it starts to cool down until it hits the dew point, where it condensates and it goes back into water droplet form and forms clouds. And it starts the process all over again. All right, so that is it for the notes. If you have any questions, please don't hesitate to ask, and I hope you guys have a great day.